welcome everybody to the EUMeTrain weather briefing of this month, August the 25th. And so this weather briefing is coordinated by the Finnish Meteorological Institute. And okay, I present myself. My name is Alessandro Chiariello, and I am the EUMetCal project manager. But the actual briefing, weather briefing from the Finnish Meteorological Institute will be given by Antti Kokko, so my colleague from the forecasting service, sitting just next to me. And today also I have the pleasure to welcome the Israel Meteorological Service, the IMS, that will give a theme presentation after the weather briefing. Very interesting case study about a plume case in the Israel that is producing hazardous weather. And also why IMS here? So the IMS just has recently joined the EUMET, and he's participating as a partner in the EUMeTrain project and also in the EMA project. So I will repeat this later, but really a warm welcome to IMS as a partner of EUMET, and really congratulations. And so we are looking forward to a good cooperation with them. Okay. As always, I would like to make a very small investigation about the audience, the background of the audience here. So I don't know. I believe that you can, as already many people are doing, you can mark up in the slide, put your markup. So if you could kindly mark up what is your background, as you are a forecaster, a trainer, a manager, a researcher, or something else. So as always, we can see that most of the people are forecaster. The audience is has a forecaster background. Some people are also trainers, researchers, and then we have other people. But I won't ask what are these others, and some managers as well. Okay, so it's time now to give the floor to open the actual weather briefing. So I will give the floor to my colleague Antti Kokko, sitting next to me. Thank you. Bye-bye.
Thank you, Alessandro. This is Antti Kokko speaking. Good afternoon. Let's now take a short synoptic outlook to the current European weather situation. And I'd like to start from the upper troposphere with presenting geopotential height from level of 300 hectopascals, and also water wave satellite image. These are both from this morning, 03 UTC time. I guess you can find from here easily upper lows, like in here. Maybe you can see my laser points, or in here. But I would like you to think, or even place, if you can draw here or mark somehow locations here where these. Okay, I try to speak a bit louder. Maybe you can all hear me. Is it better now? Okay. I try to hold the microphone in front of my mouse. Maybe now, is it better now? Okay, I'll continue. Okay, yeah. A little bit better. Thank you. Okay, so place here on this map locations of jet streams. I'm not sure if you can mark those so that we could see it where they could take place. Yes, with the stars at least. Or you can actually draw a line. There's the green line from someone. Oh, yes, very nice. Thank you. Yes, that looks good. Very good. Okay, I can see that you are familiar with this water vapor channel and how the jet streams are related to that one. Okay, that's good. Thank you. Let's now change to the next slide. And there you can see them. Well, sorry. With violet color you can see the location of the model field from the European Central Model. The wind speed at 300 hectopascals and only values 30 meters per second or more are being displayed, and that's the very place you were marking. So very good. Okay, and then the next thing, here we have just 500 and then temperature from 850 hectopascals. And now you can recall maybe the major jet stream going from Biscay to Scandinavia, and you can see that okay, there is a gradient in temperature in the level of 850 hectopascals. Also in the same region, it's even quite sharp. And maybe you remember so-called law of geostrophic wind, and you can actually see that it's really working. That's how it happens in the real life as well, or in the model life, but that's there. It really exists. Sometimes it's funny to spot these kind of things. But okay, what else we can see from this map? If we are looking for this reddish or even violet colors in this map, you can spot temperatures of 20 degrees or even more at this 850 hectopascals level, and it's really warm air mass in the area of Spain, Portugal, France, Germany, Belgium and so on, especially inside that upper high. I'm not sure how typical is it in southern or central Europe. In Finland that would be really extreme. Okay, now I've got a new slide. Here we can see observed sounding from Western Germany this morning, 06 UTC, and we can see that the model seems to be quite right. It's really warm the air mass, about 22 degrees. And now I'd like to ask you that what would be the maximum daytime temperature in Western Europe if the air mass temperature is this 22 degrees and we have clear skies in this sounding we have. Let's wait a while. Okay, maybe someone is still typing, let's wait. Okay, quite a nice variation we have. The lowest value would be 29 degrees and the highest 37, 25 is someone offering. Okay. Well, in Finnish conditions we have a rule of thumb during summertime. If the temperature in 850 hectopascals is something, then we can expect that if we add 15 degrees to it, then it's the surface maximum temperature during daytime. So yes, it will be around maybe even 37, quite close to 40 degrees. Let's now see what the model is forecasting. Here is the surface temperature for this afternoon during UTC, and you can spot something like 35. It's quite a small text, but maybe you can find those digits. Ah yes, someone is actually writing there that there is rule of thumb. Oh, it's Alessandro. Yes, thank you. It's good to see that it has written as well. Proceeding to the next slide. And there is actually in a meteor alarm, was it this morning, some hours ago, orange temperature warning in some parts of France and also Belgium. I'm not sure if it has been updated, might be also in Germany, I guess. Okay. That was it from our part, from Finnish Meteorological Institute.
Yes, so thank you very much, Antti. Okay, so sorry for this. Antti is sitting just next to me with another computer. Yes, so we could hear the very good weather briefing from Antti, and now it's my pleasure to welcome the Amit from the Israeli Meteorological Service. So again, welcome to the IMS, to the cooperation with the EUMETNet, specifically with the EUMETCAL and EMA projects. And it's really a pleasure this is the first time for you to attend this kind of weather briefing, to step into the European audience. So please, Amit, you will be telling us about interesting things. So,
okay, thank you very much.
The floor is yours.
Okay, thank you very much. My name is Amit Savir. I'm the head of the operational meteorology in the IMS, the Israeli Meteorological Service. And joining me here is Mr. Evgeny Brainin, is the head of the aviation meteorology in the IMS, and Mr. Gior Gerstein, who is the head of the international relations. And before I'll present the weather, I want to give you a quick introduction with the IMS. And as some of you may know, Israel, the state of Israel, was founded in May 1948, but the IMS, the Israel Meteorological Service, was established about 10 years earlier in 1937 by the British mandate, and today it is part of the Ministry of Transport. You can see in the upper right side of the slide the first location of the IMS. It was in the Lydia Airport, about 15 kilometers east of Tel Aviv. In 1948, after Israel was established or founded, we moved to Tel Aviv. You can see this building in the central part of the slide. And in 1962, we moved to our current location. It's in Beit Dagan, which is about 10 kilometers east of Tel Aviv. It's in the vicinity of Ben Gurion Airport, International Airport. And this is the lower left side of the slide. So we can see how we transferred from this old building into this relatively modern building which we are in today. Let's wait until the next slide appears. Okay. And if we want to understand the unique conditions Israel is characterized by, so we can see that Israel is located in the mid-latitude climatic zone. We are just right here. Our tiny country is located here. North of us is Europe. South of our country we have Africa. We are on the western part of Asia. And west of us we have the Mediterranean. We have the Mediterranean over here, and we are over here. If we zoom in, we can watch on the left map the large diversity of the topography, which is over here. You can see the western side of Israel is the coast. It is on the coast of the Mediterranean. Then we have the mountains, which starts at about 1,000 meters over here. And over here, which is Jerusalem, it's about 800 meters. Over the south, we have a desert. It is an arid zone. And over the eastern parts, we have the Sea of Galilee and the Dead Sea. And this large diversity over about 50 kilometers is causing a very large variety in the climatic zones. So even though we are in this mid-latitudes, we have a large diversity. We have snow in the upper mountains. We have a very sultry weather in the summer over the coast. We have a very arid zones in the south, so it's not boring. Our climate is not boring. And if I want to introduce a bit about our synoptic conditions, what I want to show is the synoptic types we have in our spring, only the spring. Over the left side of the slide, we can see what we call a sharav low. This is a depression causing very high temperatures, maybe sometimes up to 40 or 45 degrees, and is accompanied a lot of time by haze and even sunstorms due to the southern flow. Another system or synoptic type is called a Red Sea trough. It is named after, of course, the Red Sea, and is causing a combination of very unstable weather, very unstable conditions. You can see the thunderstorms, and on the other hand, it can cause foggy conditions along the coast. You can see the symbol of the fog. It's supposed to be a symbol of fog. And the forecasters have to decide sometimes if we'll have the thunderstorms, if we'll have foggy conditions, and where it will occur. So it's very complicated synoptic situation, which the forecasters doesn't like. And the right map shows, as many of you are familiar with, is a low depression, a depression, a wintry depression. We call it a Cypress low, named after Cyprus. And it causes our winter. We have rain and strong winds, but during the spring, it decays gradually, and towards the summer, we don't get it at all. Our summer is very dry, very hot, and along the coastal regions, it is sultry. We have high humidity and high temperatures. So this is, in a nutshell, is our spring conditions. And after giving you this short introduction, I want to go and introduce our synoptic situation, which we have chosen for you. It has occurred on May 2014. It is a tropical activity over the Eastern Mediterranean. And before showing all the slides, I want to start by showing you a short video. I hope it will work. The video shows you flash floods. So now we'll move into the video. We'll start it.
כל רוחב הנחל, עם סלעים, אני רואה את הכל.
You can hear it in Hebrew. You can see the water running very rapidly from the upper side of the creek, and you can see as it suddenly goes down the stream in a very surprising way. It comes with no warning, and if someone is over here, and as you can see, it is very surprising. If you are not, if you don't get any warning, it can be a life danger. We had many cases in the past where people have died due to this condition. So the weather I'm going to show you, to introduce you, is causing these flash floods, and that's why they're very interesting and very dangerous. So first of all, these conditions is originated in Western Africa, Israel. Just a minute. Israel is over here, and the moisture flux starts from here, from Western Africa. It goes along this path and brings us a lot of moisture, a lot of humidity in the mid layers, about 700 millibars, 600 millibars and above. And you can see it very clearly in this water vapor satellite image. You can see these areas are very dry, they are black. And as I said, this is the jet stream, or a tropical plum, which brings the moisture from the tropics. Another slide here can show you if we look at the back trajectories, we can see the origin of the air mass, again coming from Western Africa. And you can see in this cross-section, you can see as it comes to Israel, it rises, it goes up to the 500 millibars, about 300 millibars. And on the right side of the slide, you can see the jet stream, and which activates all the moisture, activates all the humidity, and causing this severe weather. And on the right bottom of the slide, you can see the moisture flux coming from south, as I said, from the tropics. The combination of the jet stream and the moisture and the hot condition, as I said, it is May, and sometimes it's April, are causing a very unsettled weather, very extreme instability, which causes very heavy thunderstorms and floods and hail at times, which can cause a lot of damage. And sometimes people are killed, unfortunately. These are two satellite animations. The left one is a usual, a normal infrared satellite. You can see Israel is over here, and you can see all the medium and high level clouds coming from the south. In a minute I will show you an animation. And on the right side you can see the water vapor. You can see all the moisture coming from the south, causing a lot of clouds over Israel. Now when we show you an animation, you can see in a minute after it will work, you can see how the southern flow causing all the heavy clouds with thunderstorms. You can see all the yellow spots, they are thunderstorms, they're cumulonimbus clouds. And you can see the rapid development of the clouds. It can happen in a couple of minutes sometimes, and you have these flash floods, which is very surprising, and as I said, it can cause a lot of damage. And now we'll go to the next slide. This is the animation of the water vapor image, and you can also see, as earlier, let's see if it works, you can see all the moisture coming in the upper levels. You can see Israel here, and it causes the severe thunderstorms. And you can see west of Israel, over Egypt, the atmosphere is very dry, so it is concentrated over the eastern part of the Mediterranean, from Saudi Arabia all along Israel. Okay, so now we have another two animations. The right one is an animation of the rain radar. I hope in a few seconds it will start. It is supposed to. And the left one, in a minute I will show you, it is the Cosmo model we are using, and we can see the precipitation. So now we will go to the animation. Now you will see the formation of the rain. You will see in a few seconds the southern orientation of its development. You can see it goes from south to east with heavy thunderstorms. You can see all the rain, the green spots, which are very heavy rain, and you can see it moving north very quickly, and it can happen, as I said, within a couple of minutes. We have heavy rain over the desert, and it's causing flash floods. And the next slide Okay. The next slide will show you a forecasted tephigram. In Israel, we usually use tephigram and not QT. So the tephigram, the animated tephigram, is from a city or a location in southern Israel where the central part of this activity has occurred. And now you can see the animation. You can see within a few seconds the formation of the cumulonimbus of the very developed clouds. You can see a lot of moisture coming and filling all the atmosphere from lower layers up to the upper parts. And you can see the very severe thunderstorms which have occurred and causing, as I said, the rain and the hail, and causing very severe and widespread floods along this event. Okay. Now let's move along to the next slide. And if I want to summarize what I have just said in the last past 10 minutes, so we can say that the tropical plumes are typical for the autumn and spring in Israel. They are usually in October and November, but sometimes occur even in April and in May. And they are characterized by significant medium altitude clouds causing, as I said, a heavy rain with hail and flash floods, and mainly over southern Israel, which is the desert areas, the arid areas of the country of Israel. And the weather activity increases towards noon and weakens usually during the night when the ground cools. And finally, one single event can produce as much as 3 to 10 times the seasonal precipitation average. As I said, this is the desert. The annual average rain is about 20 to 50 or 70 millimeters. And in one event like this, we can get as much or as high or as 80 or even 100 millimeters in one single event. So this is why it is very extreme, and it's very interesting.
Thank you, Amit. Okay, so next weather briefing will be EUMeTrain monthly weather briefing will be next month in September, the 22nd of September. So you're welcome, and you know where to register. And also, I would like to anticipate that we are going to change very soon this software that is used to deliver the presentation, and at that time, animation won't be anymore a problem. So I'm very happy for this. Okay, thank you very much for attending, and see you next time in September 22nd.